Dear students, now I am going to explain you about the third unit, periodic classification of elements. Okay, more than 100 elements. First, initially in the old Stone Age period itself, there are so many elements discovered. Without knowing that element, the human beings use that elements. Okay, after that, Lavoisier in 1789 Lavoisier came and he published the first list of chemicals elements containing 23 elements. After his experimental investigation, he identified 23 elements and he classified that substances, chemicals, elements into four groups. He classified that elements into four groups, and the elements, namely, first one, acid making elements. First one is acid making elements, that is sulfur, phosphorus, carbon, acid making elements. And the second one, gas like elements, and third one, metallic elements, and fourth one, earthy metals. He classified that 23 elements into four different groups based upon their properties. Okay, acid making elements, first one; second one, gas like elements; third one, metallic elements; fourth one, earthy elements. And in acid making elements, they are sulfur, phosphorus, carbon. And gas like elements, light, next one, heat, oxygen, azoate means it contains azo group, means azo means it is having nitrogen, n double bond n, it's called as azo group. Okay, next, caloric means heat, gas like elements. Next one, metallic elements, example, cobalt, CO, cobalt, mercury, tin, Sn, tin, copper, Cu, nickel, Ni, iron, gold, Au, lead, Bb, and Ag, Zn, Mn, and Sn. Okay, Mn and Sn, and then platinum. Okay, and then the earthen elements or calcium oxide, that is lime, and then magnesia is magnesium oxide. Another one, borate, that is barium sulfate. Next one, argilla, that is Al2O3, that is alumina. It is otherwise called as alumina. It is otherwise called as alumina. Alumina is the aluminium ore. Okay, this is a ore for aluminium. He discovered 23 elements by his experimental investigation, and the 23 elements are classified into four groups. They are acid making elements, second one, gas like elements, third one, metallic elements, fourth one, earthy elements. Okay, next, classification of elements. The elements, now we discovered 118 elements, and that 118 elements are arranged in a periodic table. That 118 elements are arranged in a periodic table based upon the certain properties by so many scientists. Okay, first, Dobereiner came. First scientist is Dobereiner. His arrangement is called as triads. Triads means elements, three elements, that is three. Tri means three. Triads means a group containing three elements. He arranged that element into a group, and each group contains three elements. Okay, he arranged the three elements to form a group. Okay, based upon their atomic weight. He arranged three elements, and each three elements form a group. For example, A, B, C. These are the three elements. Therefore, it is a single group. And he says that the atomic weight of the middle element, here the middle element is B. The atomic weight of the middle element is equal to the average of the atomic weight of the remaining two elements. Here the remaining two elements is A and C. Okay, if I add, that is the atomic weight of B is equal to atomic weight of A plus atomic weight of C divided by 2. Okay, if I add the atomic weight of A and atomic weight of C, and then the remaining and we have to divide it by 2, means we get that is equal to the atomic weight of the middle element. Okay, the end element's average atomic weight is equal to the middle element atomic weight. For example, it is a first triad. This is the first triad he found. Lithium, sodium, potassium. Lithium, sodium, potassium. Here for the lithium, the atomic number, that is it is atomic weight. The atomic weight is 7 and 23 is the atomic weight of sodium. K is the K 39 is the atomic weight. Okay. Therefore, here this is the middle element. Here the sodium is the middle element. If I add the atomic weight of lithium and potassium and then divide it by 2, that will give the atomic weight of sodium. For example, that is atomic weight of lithium is 7 and for potassium is 39. 7 plus 39. I have to add 7 plus 39 divided by 2. Therefore, 7 plus 39, 46 by 2, that is equal to 23. 23 is the atomic weight of that middle element sodium. Okay. This is the first triad This is the first triad he found. Next one, second triad. This one is the second triad. Here he found calcium, strontium, barium. This is the atomic weight of, Therefore, atomic weight of calcium is 40, and strontium, SR is strontium 88, and barium 137. Therefore, if I add these two, end element, we have to add the end element and divide it by 2, that will give the atomic weight of strontium, middle element. Okay, 40 plus 137 by 2, that is equal to 177 by 2. It is nearly equal to 88. It's nearly equal to 88. 88 is the atomic weight of the middle element strontium. Similarly, this is the second triad he observed. Second triad. And then third triad. This is the third triad. Here, so chlorine, bromine, iodine. Chlorine atomic weight is 35.5 and bromine is 80 and iodine is 187. Therefore, if I add this end element atomic weight, that is 35.5 plus 127 by 2, that is equal to 81.25. This is nearly equal to 80. Okay, nearly equal to 80. And he found the triads for 3 groups. He found the triads for 3 groups. Therefore, totally 9 elements he arranged. He arranged only the 9 elements. Okay, and failure of his theory. Failure of his model is failure or demerits, you can say. All the known elements could not be fixed in triads. We can't arrange all the elements in the form of triads based upon their atomic weight. Okay. Second one, in the same group, this law was not obeyed. For example, in halogen family, first halogen is fluorine, chlorine, bromine, iodine. Okay. Here he found triads for chlorine, bromine, iodine. If I take this one, fluorine, chlorine, bromine, that is fluorine, chlorine, bromine. Fluorine, the atomic weight is 19 and for Cl 35.5 and bromine 80. This is the atomic weight of all these 3. Okay. If I add, this is the central element. If I add 19 plus 80 by 2, that will give, that is 99 by 2, that is 49.5. It is not nearly equal to, closest to the 35.5. There is a large variation between this average and the middle element atomic weight. This is the main disadvantage of his triad, Dauber triad. Okay.